In this lesson, we will learn sine, cosine and tan theta using unit circle. So let's start. First of all, what is a unit circle? If you guys have had any question, please ask frankly. So a unit circle is a circle which has radius equals to 1. So let's say this is our unit circle, and then all the lines that start from the center of the circle and goes to the end of the circle, to the boundary of the circle, are of length 1. That means the radius of this circle is equals to 1. This point in the center of the circle we usually call origin in this case. So that means its coordinates are 0, 0. Make sense? Any questions so far? Okay. So now we can divide this unit circle into 4 equal parts. So let's say we have here our x-axis. This is our center, and we have here our x-axis, and we have here our y-axis. Then these 4 equal parts are called quadrants. So this is my quadrant number 1, and now I will number my quadrant by anti-clockwise motion. So if I'm here, then with anti-clockwise motion I will go to which part of the circle? This one, huh? Very good. And then I will come to this one, and then I will come to this one. So this is going to be my quadrant number 1. This is going to be my quadrant number 2. This is my quadrant number 3, and this is my quadrant number 4. Now we have here our x-axis. We have here our, yes?
Doesn't the arrow show that the line is going up forever?
Yes, the arrow shows the line continues forever. We have here our y-axis, and now we have to first find out that what will be the values of x-axis and y-axis in different quadrants. That means if in this quadrant, for example, both x-axis and y-axis will be positive. And now let me explain this, that for the values of y-axis above 0 are positive, because we have here 1, 2, 3. Not in this case, if it is unit circle, we will not have here 1, we will have 1 here, but we might have here 0.1, 0.2, 0.3, 0.4, 0.5 and so on. Make sense? So the values above the center of the circle are positive for y-axis. Similarly, values below the center of the circle with respect to y-axis are negative. So we have here minus 0.1, minus 0.2, minus 0.3 and so on, right? And so we have here positive this way, positive, and this way negative. Make sense? Similarly, in case of x-axis, the values to the right of the circle are positive. So these are positive this way, and the values to the left of the circle will be negative. Make sense?
Yes.
So now we can find out that what will be the x and y values in this part of quadrant. With this quadrant, quadrant number 1, our x will be, because x will be this direction, y will be this direction. So our x will be positive and our y will also be positive in this quadrant, because we will have x's here and y there, and so both will be positive. What about this quadrant? Yes?
The y will be positive and the x will be negative.
Very good. But we first have to say x. So our x will be negative and our y will be positive. What will about this quadrant?
Both of them will be negative.
So very good. Both will be negative. What about this quadrant?
The x will be positive and the y will be negative.
Very good. X will be positive and y will be negative. So that's good that you have grasped the basic concept about quadrants. So if the radius of this circle is 1, that means from the center of the circle to this point, our x-axis will be 1, right? And our y-axis at this point, our x-axis will be 1 because the radius is 1. And what will be our y-axis?
Also 1.
No, because this point is 0, 0, and we have not traveled anything, we have not traveled along y-axis. So our y-axis will be
0.
0. Now, what about this point?
The y-axis, the x-axis will be 0 and the y-axis will be
Very
1.
good, you are very intelligent. Our x-axis will be 0 and y-axis will be 1. Now, what about this point?
The x-axis will be 1 and the y-axis minus 1 and then 0.
Very good. What about this point?
Minus 1, no, 0 and then minus 1.
Our x-axis will be 0 and y-axis will be
Minus 1.
minus 1. So now let's add a vector inside of circle. So I have to first clear these things. So assume that I have a vector whose origin of the vector is center of the circle, and the vector length is 1, so it touches the edge of the circle. So the vector is of length 1, and I have to find that what are these points. So I can, using our method of I hat and j hat, I can find that this point is that first I have to go towards this direction, and then when I am at the 90-degree angle from this point, then I will go up, right? So first this direction and then up. So this angle will be 90-degree angle. So I have a right angle triangle here, and the length from here to here, maybe I have gone x unit this direction, then this length will be x. If I have gone y unit this direction, then this length will be y. And the coordinate of my vector or end point of my vector will be, let's say, p, and it will be x comma y. So basically you can say it's x I hat plus y j hat, right? So what we have here is a right angle triangle, and length of this line from here to here is x, and length of this line from here to here is y. So that the vector from here to here is x comma y. And because it's a right angle triangle, so for this triangle we have x square plus y square equals to 1, because we know that with Pythagoras theorem, base square plus perpendicular square is equals to hypotenuse square, which is 1 square, but 1 square is equals to 1. Make sense?
Yeah.
And in this case we usually choose this theta, but we can choose this theta also, but mostly we choose this angle as our theta, and we find values of sine and cos using this angle. So now let's find what will be the value of sine theta for this triangle. So we know two different kinds of mnemonics. We know one SOHCAHTOA, and we also know some people have curly brown hairs through proper brushing, which is the second one is more liked by us. So we're going to use the second one. So according to the second one, we know that some people have, that means sine theta is equals to perpendicular upon hypotenuse, and curly brown hair, so cos theta is equals to base over hypotenuse, and through proper brushing, so tan theta is equals to perpendicular upon base. Make sense? And because we have chose this angle as theta, so this is going to be our base. So our base is going to be, our b is going to be x, and this is going to be our hypotenuse, because hypotenuse is always opposite to the 90-degree angle. So our hypotenuse in this case is equals to 1, and the angle opposite to theta is called the side opposite to theta is called opposite, or it's called perpendicular. So our perpendicular is going to be y. So the perpendicular is going to be y. And now we can use these quantities and fill these quantities in these formulas. So our sine theta is going to be perpendicular upon a hypotenuse. It's going to be y over 1, but we don't have to write 1 because 1 is 1, right?
Yeah.
So sine theta is going to be 1. So cos theta is going to be our base over hypotenuse, which is base is x, going to be x. So our cos theta is base, our sine theta is x. And our tan theta is going to be basically y over x. That's our tan theta. So that's why some people sometimes write that this point in the unit circle is not x comma y. They write this point in the circle is this point P is cos theta comma sine theta. Why they write this? Because we have find out that x is equals to cos, so they just replace x with cos and they just replace y with sine. Make sense? Anything is clear so far?
Yes.
Okay. So now what we have to do, we have to use this circle, and now our target is to find calculate sine theta and cos theta at different points. Make sense? So now let's clear the board or clear part of the board and then find sine theta and cos theta at different points of the circle.